Hi everybody. I'm really excited about this opportunity to still be able to teach you even though I'm not here. I hope this video was helpful. Be sure to take notes along with what I'm saying, listen to what I'm saying, jot down other useful, helpful things, and yeah, it should be like I'm not even gone, except you won't be able to ask me questions, which of course makes it a little more difficult, but I have confidence in your ability. I have confidence that you can use your brain to figure out these problems and answer your own questions based on the notes. So, be sure to treat my subs just as well as you treat me. I would hate to come back and find out that you disrespected any of the substitute teachers while I was gone. That would not be very cool. So, yeah, I guess let's just jump into this. Okay. In previous days, in fact, this past Thursday, we learned a lot about slope. Okay, we learned what slope is, how it's the change in y versus the change in x, and we did that whole TARP activity to help us visualize and get our bodies involved in the learning. Now, I'm not here with you today, so I'm going to be able to only do these notes with you guys. We don't have any kind of physical activities to practice any of this, so be sure you're taking close notes and following along. So I want to start right here where it says the measure of steepness. Okay, the measure of steepness of a line, m, is called slope. Okay, we call it slope. In a linear function, the slope represents the comparison of the changes in variables. Okay, it's the ratio. You remember that word? A ratio is also the same thing as a fraction. Okay, it's the ratio of the change in the vertical distance to the change in the horizontal distance. Okay, vertical. Do you remember vertical on a graph would refer to which axis? Well, it would refer to the y-axis, whereas horizontal would have to refer to the x-axis. Now, I know my handwriting is really bad here. I'm using a stylus that I don't normally use. I'm writing on my iPad. That's where I'm recording these videos. So be sure to listen to what I'm saying as well as watch what I'm writing, and use your brains a little bit when you see what's on the screen. Okay, so we talk about slope as a change in y versus the change in x. Okay, so let's look at this example right here. Okay, when we see this line, they've identified 2 points for us. Okay, that made it a little bit easier for us. And they've even done some of the work for us right down here. Okay, right here they did some of the work for us. They talk about the vertical change over the horizontal change. Okay, now where did they get those two numbers from? Well, if we start at this point right here and we go 1, 2, 3, 4 up, that's a positive 4. Okay, we moved in the positive 4 direction. Okay, so that's our change in y, our vertical change. That's where they get this 4 from. And then once we reach that point, we go 1, 2, 3, 4 to the right, which we know is a positive change for our x, our horizontal change. That's where they get this positive 4. Okay, and we know 4 over 4 reduces to 1, or simplifies to 1. So that vertical change was described right here. We went up 4, and we went to the right. Oops, not there. Let's try that again. Oh, come on. No, doesn't want to back out of that? That's weird. I guess not. Okay, ignore that blue mark, and let's do this blue mark instead. To the right, 4 spaces. Okay, so we've got this vertical change of 4 and a horizontal change of 4. So that's where these numbers came from right here. And as a reduced or a simplified fraction, we get a slope of 1. Now, if you remember what we did on Thursday, that slope of 1 tells me that if I do anything that equals 1, let's say that I want to go up 3 and to the right 3. Notice this fraction equals 1, doesn't it? So if I start at our last point here, this one right here, and I go up 3, 1, 2, 3, and to the right 3, 1, 2, 3, I've landed on the line again. See where that pointer's right there on the line. I could do any interval that equals 1. I could do 5 over 5. Okay, let's start right here and go 5. 1, 2, 3, 4, 5. And if I move to the right 5, 1, 2, 3, 4, 5. that gives us another point on the line. So this slope of 1, no matter what version of the number 1 we give, we will always land back on that line. Okay? So it says if another 2 points were selected and the ratio of vertical change to horizontal change was calculated, would it also equal 1? And they want us to verify our answer. So let's choose 2 more points on this line somewhere. Let's choose, I don't know, this guy right here. Now notice I'm trying to choose a point at where the little lines intersect, so that they call it an interval point. It's where the numbers are whole numbers. Okay, let's choose that point, and then let's choose, I don't know, this guy right here. Okay, do you think that if we count up the vertical change and the horizontal change, that our slope will still equal 1? Well, let's test it out. I'm going to use my little arrow here. All right, let's do our vertical change. 1, 2, 3, 4, 5, 6, 7. We moved in a positive direction 7 spaces. So my vertical change here is a 7. Let's go back down here so we can write it here. Okay, our vertical change is a positive 7. Let's write that a little differently. Why is it not? That's frustrating. Okay, let's try this again. 7 over, okay. Now, if we go back here, so we went up 7 to get to here. Now we have to go to the right. 1, 2, 3, 4, 5, 6, 7. Okay, so we had a horizontal change of 7. So if I do that down here, I see what's happening. This isn't, that's interesting. Weird. Let's get rid of this guy. Okay, let's try this again. 7 over 7. That's terrible. That is terrible. And it doesn't want to go away. How strange. Okay, so our ratio here, we had a vertical change of 7 over a horizontal change of 7, which still equals 1. Now it says if the y value of a linear equation increased by positive 4.5 when the x value increases by 1, what is the measure of its steepness? They're basically saying y value refers to our vertical change. Okay, this guy right here is the vertical change. So if that's 4.5 and our x value increases by 1, so our horizontal change is 1, what is the slope? What is the measure of the steepness? Well, 4.5 over 1 is still just 4.5. Okay, so that would be our slope, our steepness. Sorry about that, my phone rang. Let's go to the next page here. Okay, so a 4.5 change in our y value versus an increase of 1 in our x value. So we set it up the same way. We have our vertical change. We have our vertical change here and our horizontal change there. So we simplify after we've set up that ratio. All right, let's go to. Okay, so slope is represented by the variable m in the equation y equals mx. Now, the equation of a line extends past that. We talked about this on Thursday. The equation of a line is truly y equals mx plus b. And I told you not to worry about the b because we would talk about that next week, which is still true. Okay? On November 3rd, which is next Monday, we will talk about the b value. Now, let's see. The m variable is what we're focused on today. It's the slope, okay? The m variable, this guy right there, okay? So in example 1, it says, how could you find the slope by looking at an equation of a line such as y equals 3.2x? Well, if the slope is our m, and in the equation y equals mx, okay? So if I were to write that general form right here, y equals m, let's try that again. Okay, y equals mx, what does it look like is in the same position as the m variable? Well, in this equation, it looks like the m equals the 3.2. It's what we call a coefficient. Remember that word? Any number that's bumped up against a variable, like 3x or 10x or something like that, that's a coefficient. In this case, the coefficient of the x is our slope. Now, in example 2 here, it says, the slope is one of the parameter changes that affect the linear parent function. It says, summarize the effects of changing the slope m on the graph. Now, these are just a couple of rules, okay? When the slope is positive, we talked about this on Thursday, when the slope is positive, I'm going to make this just a little bit bigger. Okay, when the slope is positive, the graph goes up. It goes up from left to right. Okay, it goes up from left to right. When the slope is negative, again, we talked about this on Thursday, when it's negative, the graph goes down. I'm not going to write everything I say because it's a little bit hard to write with this stylus. Okay, so it goes down from left to right, from the left side to the right side. Okay, I would prefer if you use the real words. Okay, I'm using symbols because it's a little bit easier. Okay, when the slope is negative, the graph goes down from the left to the right. Okay, now here's a little bit of new information. When the slope m is greater than 1, that means any number bigger than 1, okay? Any number bigger than 1, the graph gets steeper, okay? And we'll talk more about this when I get back and things, but the graph gets steeper. You guys know what steep means, okay? When something is really steep, you would roll fast down it, right? Or you, like if you were on a bike or something and you're going down a steep hill, that bike would go really, really fast, and you'd pick up speed with a steeper hill. Okay, and when the slope is between 0 and 1, we're talking about fractions and decimals like 1/2, 0.6, 0.25, 3/4. Okay, any fraction that is between 0 and 1, the graph gets flatter or less steep. Okay, it gets flatter, and we know that you're riding a bike on flat ground. You're not going to pick up speed unless you pedal, right? It gets flatter, it gets less steep. And when the slope is changed, when we change the slope, the y-intercept, which we'll talk more about on Monday, the y-intercept stays the same. Stays the same. Okay? Again, we'll talk more about the y-intercept on Monday. Right now we're focused on the slope. But what they're saying here in letter E is that changing the slope does not necessarily change the y-intercept. Okay? Those are two separate parameters that control the linear function, and the slope does not control the y-intercept. Now, in example 3 here, they say the slope of the graph of the parent function is y equals x. This is a very important bit of information right here. We call it the parent function. It is the most basic of all the linear functions, and it's y equals x. Okay? The slope of this graph is 1. Okay? That means that when the x increases by 1, okay, if my slope is 1, say 1/1, when my x increases by 1, my x increases by 1, let me do that again. When my x increases by 1, my y does what? Well, it also increases by 1. Okay? That's the parent function, the most basic of all of our linear functions. Okay? It has a slope of 1, which tells us we go up 1 and to the right 1. That's a positive 1 slope. Has a vertical change of a positive 1, has a horizontal change of a positive 1. Okay? We go up 1 and to the right 1 from this point to this point on a line. Okay? That's what our parent function has. Our parent function follows a slope of 1. All right, now, we have practiced this a little bit. We did this on Thursday a little bit. We practiced it a little bit on Friday. Okay, finding slope from a graph. Okay, it says in order to do this, these are the steps to find the slope from a graph. Okay, and it says, like I've said before, preferably integral values. Okay, whole numbers if you can. It says locate 2 points on the graph, preferably integral values, and compare the vertical change to the horizontal change. Look, here it is again, the same thing that we keep seeing over and over again for slope. Vertical change over horizontal change. Vertical change is also called the rise, and if it's going up, we have a positive. If it's going down, we have a negative. And our horizontal change is also called the run. Okay, and I'm actually going to do that in a different color. Come on. There we go. Okay, we're actually going to do this in a different color just to kind of keep things separate. When we move to the right, it's a positive. When we move to the left, it's a negative. Okay, so what does that mean, okay? That we have this graph, okay? And let's say that on this graph we have a line that, I'm going to do my best to draw a nice pretty straight line here, no guarantees. Let's try to do the parent function, okay? Let's say we have this line. It's going, it's going, it's going. I'm doing okay. It's a little shaky. I'm getting there. Just making sure to hit all the right points. It's not perfect. Oh, there it goes. I knew it. Okay, let's try this again. There we go. All right, so we've got this line. Okay? Let's say we want to figure out what is the slope of this line. Well, our steps tell us to identify 2 points on the line, preferably integral values. So I'm going to try to find a couple points on the line where they're whole numbers. Say this guy. Those are integral values because it's where 2 little blue lines come in contact. And let's say, how about this guy? Okay, 2 random points on the line. Now, in order to get our slope, we need to count our vertical change. We'll do that in red. And then our horizontal change, which we'll do in blue. Okay, so let's do our vertical change, our change in y. So we go 1, 2, 3, 4, 5, 6, and 7. Okay, so I went up 7, positive 7. So I'm going to put that over here. Remember, it's our change in y over our, ooh, that's a terrible y. Change in y, you see I'm not much better drawing on this thing than I am on the board, over our change in x. So our change in y was a positive 7. What is our change in x? Okay, our change in x. I'll do that in blue, okay, since I'm going to count it in blue. All right, so I'm here. Now I go 1, 2, 3, 4, 5, 6, 7. Well, that's a positive 7 as well, right? This was a positive 7 change. So I have positive 7 here. Now, we've practiced this. We practiced this on Thursday, and we did a little bit on Friday also, okay? So you know how to count the slope on a graph. Find 2 points, count your vertical change and your horizontal change, okay? So this was just a kind of an example to remind you how that worked. I know you've had a weekend, and you've slept a couple times since then, so let's just make sure we remember how to do all of this, okay? Now, Miss Ellison is going to pass out a practice set where you're going to practice doing this. You are going to simply find the slope as a rate of change. You're going to find it on the graph, okay? It's going to give you 2 points, it'll give you 2 points or a line or something like that, and you're going to tell me what the slope is. Now remember, we do have those special cases we talked about on Thursday. A vertical line is always an undefined slope, and a horizontal line is always a 0 slope, so pay attention to those as well.